Hello students, we all know that normally when we travel in a bus or a car, we experience a forward push when the vehicle slows down, when the brakes are applied, and we experience a backward push when the vehicle accelerates. This concept or this experience is because of the inertia of the body. For example, if I suspend this pendulum in a car and if the car is accelerating forward, the pendulum will shift back. Whereas if the car is slowing down, the pendulum will move forward. Now using this pendulum, I have calculated the speed of the aircraft. Recently I have traveled with Indigo Airlines and I have performed the experiment in the aircraft Airbus A320, in which I have calculated the takeoff speed of the aircraft using this simple pendulum. So let's have a look at that experiment.
Okay, so right now I'm in Indigo Airline Airbus A320 and I have suspended the pendulum, and pendulum is vertical as there is no acceleration of the plane. The engines are going to start now and the acceleration of the plane is going to start. You will see that the pendulum will start tilting back. So here we go. So you can see that the pendulum is shifting back by 8, 9, 10, 12, 13, 14 degrees, constant acceleration. The pendulum is tilting back by constant value of about 13 to 14 degrees, constant acceleration. You can see that I have to touch the pendulum in order to avoid any kind of oscillations. So I'm just making sure that pendulum will remain steady at that 14-13 degree as acceleration of the plane is tilting it back. So it is about to take off. The plane is about to take off and here it leaves the ground.
Okay, so from the experiment, the data that we got was at t equal to 0, the plane was at rest on the runway and then it started accelerating. It started accelerating for almost about 32.84 seconds that we have recorded on the timer. For 32.84 seconds, the plane accelerated and then it took off. So we have to calculate the speed of the plane when it takes off. So the takeoff speed of the plane we are going to calculate. For that we must know the acceleration, and we saw that the pendulum was hanging somewhere between, it was oscillating between 15, 14 or 13 degrees. So 15 to 13 or 12 degree the oscillations were. So I would take some angle about 13.5 degree plus or minus 5%. There will be some error in it because we are not sure, the camera angle was also tilted. So we will take approximately the mean or the average of those readings, that is 15 was the maximum, 12 was the minimum. So the angle I have taken is the average. So what is meaning of this angle and how I can calculate the acceleration using this angle? See, for that you must know, if there is a pendulum suspended in a stationary object, stationary vehicle, for example a pendulum is suspended in a stationary vehicle, the pendulum always hangs vertical because acceleration due to gravity is in downward direction. But now if this vehicle starts accelerating forward, the objects inside this vehicle will experience a backward acceleration called as pseudo acceleration because of pseudo force. And that acceleration, pseudo acceleration, is always equal to the acceleration of the vehicle. If the vehicle is accelerated forward, the pseudo acceleration will be backward in the same value in the backward direction. So this pendulum is experiencing two type of accelerations when the vehicle is accelerating. First one is downward because of gravitational acceleration, and the second is backward, that is the acceleration of the plane. So the angle that it is making, theta, is because of two. Downward is acceleration due to gravity. The second one is pseudo acceleration, which is actually equal to the acceleration of the moving vehicle. So how to calculate this angle using these two? Tan theta will give me A by G, and I can calculate acceleration using G tan theta. Since we know the angle which the pendulum was making during the entire journey, so I can treat that acceleration constant because angle was almost constant. So 9.8 is acceleration due to gravity times tan of 13.5 degree. Plus or minus 5% there is error, so there will be error in acceleration as well. So it comes out to be 9.8 if you solve it using log table or calculate the value in calculators. you will get it about 0.24. And on solving this, you have to multiply 9.8 into 2.24 on multiplication. So 2.352 meters per second square is the acceleration of the aircraft. So acceleration of the aircraft we have calculated, and it was accelerated for 32.84 seconds. So what will be its takeoff speed? We need simply kinematical equation number 1, and that is, since the acceleration is constant, I am using this. V is equals to U plus AT. Since we know that initially, before the journey started, the plane was at rest, so initial speed is 0, plus acceleration is 2.352 times the time for which acceleration took place. We have recorded on the timer, it is 32.84 seconds. And if you multiply this on calculator, you will get the value about 77.24 meters per second. This was the takeoff speed of the aircraft. Takeoff speed. And in meters per second, if I convert it into kilometers per hour, I need to multiply this with 18 by 5. The factor of converting meter per second into kilometers per hour is 18 by 5. And on solving this particular thing, you get the value roughly 278. On solving this on calculator, you'll get the value 278.06 kilometers per hour. So this was the takeoff speed of the aircraft. Obviously the error is about 5%. I've assumed error about 5%, so there will be error about 5% in this as well. So finally, the speed of the aircraft during the takeoff speed is about 278.06 kilometers per hour. Plus or minus 5%, there is a chance of error because of the readings. If you convert it into miles per hour, it comes out to be 172.77 miles per hour. This is the takeoff speed of the aircraft.